This isn't one of those simple stories with a clear villain. This is the story of a brilliant problem solver, an invention that was hailed as a breakthrough, and a mistake of catastrophic proportions. It's the story of how a solution became one of the worst public health disasters of the 20th century, a silent poison that literally chipped away at the potential of entire generations, all without them ever knowing.
So to really get our heads around how something this catastrophic could happen, we're going to break it down, almost like a forensic investigation, into 6 chapters. We'll follow the thread from a simple mechanical issue all the way to a global poisoning, and finally land on the tough lessons it still holds for us today. Let's start with the machine that started it all.
Okay, so let's set the scene. Picture it, the early 20th century. The car is this brand new, exciting invention, and it's promising to completely change the world. But this incredible new technology was being held back by a really fundamental and really violent problem happening deep inside the engine. A problem they called knock.
What you're looking at here is the heart of the problem. A healthy engine is all about a controlled, smooth burn of fuel. Think of it like a firm, steady push on the piston. Engine knock is the exact opposite. It's a chaotic, premature explosion, a detonation, that sends a shock wave through the cylinder. The engine is literally fighting itself, which causes damage, kills power, and put a hard ceiling on how powerful these new machines could ever get.
So to see where it all goes wrong, let's just quickly walk through a normal engine cycle. First, you have intake, pulling in fuel and air. Then compression, which squeezes that mixture to build up energy. Then, at the perfect moment, the spark plug is supposed to ignite it, creating the power stroke. But here's the problem. With knock, the fuel mixture explodes way too early during the compression stroke, before the spark plug even does its job. This one, single, uncontrolled explosion was the biggest thing holding back not just cars, but airplanes, and really all of industrial progress. Solving it was the engineering puzzle of the age. And the man tasked with solving it was an engineer over at General Motors named Thomas Midgley Jr. Now, it's really important to see him not as a monster, but as everyone saw him back then, a brilliant, tireless inventor. His job was to fix this very real, very urgent problem. He was on a mission to find a solution. The question, though, is what if the solution turned out to be far, far more dangerous than the problem itself?
So Midgley and his team, they go to work. And I mean, they test thousands, literally thousands of different compounds, looking for something that would stop the knock. And then they found it. A compound called tetraethyl lead, or TEL for short. It worked perfectly. It was cheap, it was effective, and it completely silenced that violent engine knock. From a purely mechanical standpoint, it was a miracle.
So how in the world did it work? Well, you can think of tetraethyl lead as a kind of chemical referee inside the engine. As the fuel and air are getting compressed and heated up, the TEL breaks down and releases lead atoms. These atoms go around and basically calm down the most volatile parts of the fuel, these things called free radicals, that would otherwise cause that premature explosion. Adding just a tiny drop of this stuff to gasoline boosted its octane rating through the roof, and that meant car makers could build much more powerful, high-compression engines. This was the key that unlocked the next generation of power. But right away, General Motors and its partners knew they had another problem, this time a PR problem. The word lead, even back then, meant one thing to the public: poison. So they made a very calculated marketing decision. This new additive would not be called leaded gasoline. Instead, they'd market it under this clean, almost friendly name, ethyl. And just like that, the word lead was completely scrubbed from the public conversation.
And this is where the story takes a really dark turn. The danger of lead wasn't some big secret they discovered later on. I mean, this was ancient knowledge. The Romans wrote about how lead mining could drive men mad and kill them. Doctors in the 19th century had volumes of research on lead poisoning in painters and factory workers. They knew, unequivocally, that they were adding a powerful, well-documented neurotoxin to a product that would be vaporized into the air of every town and city. And what's worse, they knew about safer alternatives, like ethanol, that also worked. But they chose the poison.
You might think a disaster like this takes decades to show up. Not this one. The consequences of that choice, they were almost immediate. As soon as factories started producing tetraethyl lead, the workers inside those plants became the very first casualties.
There was this one plant in Bayway, New Jersey, and the workers there, they started shaking uncontrollably. They became confused, were seeing terrifying hallucinations, and would then descend into violent madness before dying. The workers even had a nickname for it. They called it loony gas. But this wasn't some mystery illness. It was textbook acute lead poisoning from massive exposure to the chemical they were making. The danger wasn't an abstract idea anymore. It was being written in the bodies of the dead.
So what happens when the public starts freaking out? The industry goes on the defense. They don't question the product, they question the workers. This quote from an FOVP says it all. The strategy was to reframe these obvious poisonings as a simple issue of poor factory hygiene or workers making mistakes. Midgley himself played a part in this. He held a press conference where he poured TEL on his hands and breathed in the fumes for a full minute to, quote, prove it was safe. What he didn't tell the press was that the stunt left him seriously ill for months.
And this right here, this is maybe the most important scientific concept in this whole tragic story. The industry successfully made the case that the refinery deaths were caused by acute exposure, a huge dose in a short period of time, and they argued that the tiny trace amounts the public would get from car exhaust were totally different and perfectly safe. This distinction is everything. It's like smoking. If you smoke one cigarette, you'll be fine. If you smoke for 40 years, the harm is slow, cumulative, and invisible until it's not. Those workers in the refinery, they were the canary in the coal mine for acute poisoning. But the rest of the world, we were all about to become the subjects of a massive, decades-long experiment in chronic poisoning.
And just like that, the story just explodes in scale. It's no longer about a factory, it's about the entire planet. The engine knock problem was gone, but in solving it, the automobile, this symbol of freedom and progress, had been turned into the most efficient lead delivery system imaginable, pumping a known neurotoxin into the air that every single person breathed.
See, when you burn this stuff in an engine, the lead doesn't just vanish. It gets converted into these microscopic, aerosolized particles, an invisible dust of neurotoxin that settled on everything. Our streets, our farmland, our playgrounds, our water. Every city on Earth was shrouded in a low-level toxic fog, and every breath we took was a tiny, incremental dose of lead.
And who did this hit the hardest? The most vulnerable among us. Kids. A child's developing brain is incredibly sensitive to lead. Let's get into the brain for a second. At a microscopic level, lead is a great impersonator. It pretends to be calcium, which brain cells need to communicate and build connections. By getting in the way, lead basically gums up the works of brain development. And this tiny interference had massive consequences. The average kid growing up in the peak leaded gas era lost between 5 and 7 IQ points. It was a theft of human potential on a scale it's hard to even comprehend.
Now take that small amount of damage in one child's brain and multiply it by millions and millions of children across an entire generation. Decades later, researchers started connecting the dots, and they found this incredibly powerful and, frankly, disturbing correlation. As you can see, the huge spike in childhood lead exposure in the middle of the century is followed about 20 years later by an equally dramatic spike in violent crime. The theory goes that by damaging impulse control and executive function in a whole generation, lead exposure was a major contributor to that later crime wave. It just goes to show how a subtle poison can have massive, society-wide effects for decades.
It's the obvious question, right? If this stuff was so bad, why on earth did it take more than 50 years for anyone to do anything about it? Well, the answer is a textbook example of how systems can fail. The industry poured money into its own research designed to create doubt. Government regulators were often more concerned with protecting the industry than the public. But maybe most important, the harm was slow, it was spread out, and it was invisible. And that made it incredibly easy for everyone to just ignore it.
The hero of this part of the story, he's a guy who wasn't even looking for this fight. Claire Patterson was a geochemist with one goal: to figure out the exact age of the Earth. To do that, he needed rock samples that had zero contamination from modern industrial lead. And as he said, he just couldn't find them. From the highest peaks to the deep sea, the entire surface of the planet was coated in a thin layer of man-made lead. His quest to date the planet was sidetracked by a horrifying discovery. His own species had contaminated the entire world.
So how do you prove something like that? Well, Patterson was brilliant. He turned to ice cores from places like Antarctica. They're like a perfect time capsule of the atmosphere, layer by layer, going back thousands of years. And what he found was the smoking gun. You can see it right here. The data is just undeniable. For centuries, lead in the atmosphere was basically zero. Then right around the 1920s, it shoots up like a rocket, a curve that perfectly matches the sales of leaded gasoline. And then after the bans start, it plummets. It was a perfect, unambiguous fingerprint of a global poisoning event.
Patterson's work, that was the beginning of the end for leaded gas, but man, it was a long, slow end. It took decades more of brutal scientific and political fights before the world finally acted. Which just leaves you with this really heavy question.
We can count the tons of lead in the ice, but we can never count the stolen IQ points, the discoveries that were never made, or the potential that was lost forever because of a poison we chose to put into our world.
Okay, so after all of that, what's the big takeaway? What's the lesson we're supposed to learn from this whole slow-motion disaster? It's a story that really forces us to look hard at our relationship with innovation, risk, and who bears the responsibility when things go wrong.
And this is where the story of Thomas Midgley gets even more unbelievable. After he solved engine knock, his next big invention was another miracle chemical, the world's first chlorofluorocarbons, or CFCs. You probably know them by their brand name, Freon. They were hailed as the perfect, safe refrigerant. Of course, we now know they were the very same chemicals that were tearing a hole in the Earth's ozone layer. Think about that. One single person, just trying to solve engineering problems, ended up creating two of the most catastrophic environmental disasters of the entire century.
And that really gets to the heart of it. This wasn't a story about a few evil people. It was a story about a system. It was a failure of arrogance, combined with powerful incentives. The damage wasn't caused by an accident. It was caused by the product working exactly as it was designed to. The sheer scale of it all is what turned it into a poison. The harm was slow, spread out, and easy to ignore. And the system was set up to reward short-term profits while pushing the massive long-term costs onto everyone else. And every step of the way, any scrap of scientific uncertainty was used as an excuse to do nothing.
So yeah, the chapter on leaded gasoline is, for the most part, closed, but it leaves behind this permanent cautionary tale. It forces us to look around today and ask, when a new technology comes along that promises us convenience and progress, but its potential risks are hidden, slow-moving, and maybe even irreversible, have we actually learned how to ask the harder questions? History demands that we do.